These occur when two large molecules form one larger product plus water. Plus ethanol. So we are looking for the product here. So in this sidebar over here, I'm going to be writing out the steps of the reaction. The first step of any reaction problem is to draw out the reactants, just because it makes it a bit easier to visualize. The second step, which is specific to condensation reactions, is to make a water molecule. All condensation reactions have a water molecule as a product. So to do this, we're going to need to take one oxygen and one hydrogen from here, and another hydrogen from over here to make H2O. And the last step, to find the second product of this reaction, is to join the remaining chains together. So we have 1, 2, 3 with an O, and this is called ethoxy propane. Trickier than the example number 1, because instead of finding the product, we're working backwards to find the reactant. So again, the same process. We're going to draw out the information we have first. So we're going to draw the product. This is our first product. However, because this is a condensation reaction, we know that there's another product, water. So we can draw that out here. So these are the two products in this reaction. So now we're going to take a look at them to work backwards and find out which two reactants produce them. So looking at cyclopropyl butanoate, this oxygen is where the two reactants linked together to produce this product. So from that we can figure out which types of reactants came together. So if we lost one hydrogen from one of these, one side, and two in a hydroxyl group, so an oxygen and a hydrogen from the other side, we can figure out that by putting a hydrogen right here, this makes a carboxylic acid. So let's draw that out over here as one of our reactants. So start with the hydroxyl, bond it, double bond it to a oxygen, and we have butanoic acid. So that would use up one of these hydrogens from the water that was produced, as well as this whole side of the product. So what's left over is a hydrogen and oxygen, a hydroxyl group, and part of the cyclopropyl. So let's bond those together and see what we get. So there we have it, our two reactants that came together to produce the product cyclopropyl butanoate, our butanoic acid, our carboxylic acid, and cyclopropanol. Reactions are the reverse of condensation reactions. water is added to a larger molecule to break it into two smaller molecules. Product of this reaction. First step, draw them out. As with any hydrolysis reaction, water is one of the products. So we're going to use it to break down the other product, methoxypropane. To do that, we're going to take one hydrogen and bond it to one part of methoxypropane, and then we're going to take the hydroxyl group OH and bond it to the other side. So we're going to start with drawing out one half. So let's start breaking it here. And we'll break the water as well to make propan 1-ol. So that's an alcohol. With what we have left, I'm going to bond it here. O, bond it to H. So we can assume we have a CH3 over here, which is just methanol. So this question is asking for us to find the hydrolysis reaction that produces ethanamine and methanoic acid. So we're working backwards to find the reactants. The first step is to draw out the information you're given. So here are ethanamine right here and methanoic acid, the products. Although we are not given the reactants for this reaction, because it's a hydrolysis reaction, we know that water was one of the reactants. So here's our water molecule. In order to work backwards to find the other reactant, we're going to have to use up this water molecule. So if we take away this H and this hydroxyl group, we are left with two segments of the products that we can join together to find the other reactant. And this is called N-ethyl methanamide. And this makes sense because if this reactant reacted with water and it broke it down, the water would break apart to bond to each of the products, which we can see is here and here. Oxidation reactions occur when C, so the carbon chain, forms more bonds to oxygen and fewer bonds to hydrogen. This reaction will also involve a loss of electrons. There are three types of oxidation reactions. The oxidation of primary alcohols will result in an aldehyde. The oxidation of secondary alcohols will result in a ketone. The oxidation of tertiary alcohols will not result in any substance. This oxidation problem asks us to predict the product of the reaction 2-methylpentan-3-ol equals what? So the first step is to draw out, which I have done. This right here is 2-methylpentan-3-ol. Because this is an alcohol and it's an oxidation reaction, a ketone will be formed. this hydrogen will be removed. As in oxidation reactions, fewer bonds are formed to hydrogen and more are formed to oxygen. So instead, a double bond is formed to the oxygen, making the ketone 2-methylpent-3-one. Oxidation example 2. Find the oxidation reaction that produces propanoic acid. First step is to draw out the product, which I've already done. This right here is propanoic acid. So, because when an oxidation reaction occurs, fewer bonds are formed to hydrogen and more bonds are formed to oxygen, we can assume that the original reactant had the same chain and had a double bond to oxygen. Because more bonds were formed to the oxygen, this came in because no more bonds could be formed here. So another bond was formed to oxygen, and that oxygen bonded to a hydrogen. Reduction reactions are the opposite of oxidation reactions. Carbon atoms form less bonds to oxygen and more bonds to hydrogen. The reduction of a carboxylic acid will result in an aldehyde. The reduction of a ketone will result in an alcohol. The reduction of an aldehyde will result in a primary alcohol. First step is to draw it out. Here is butane 2-one. And we know that reduction reactions work to increase the number of hydrogen bonds and decrease the number of oxygen bonds. So we have a double bond at the second carbon, so that's going to break. And because we're increasing the number of bonds to hydrogen, there's going to be an H added right here. This means that the product of the reaction is going to be butane 2-ol, an alcohol. Reduction example 2. Find the reduction reaction that produces 3-chlorohexanol. This right here is chlorohexanol. It's been drawn out, and that's our product. We're looking to find the reactant that formed this. Reduction reactions always try to increase the number of bonds to hydrogen and decrease the number of bonds to oxygen. We have a hint right here. There is a hydrogen bond right here, that just like there are hydrogen bonds on all of these carbons. If there's a hydrogen here, there may have been another atom bonded that has been reduced. Oxygen is always reduced in reduction reactions. We can infer from this information that originally the product looked like this. We can confirm that this is correct because our product is an aldehyde, and we know that when a carboxylic acid reduces into a product, it's an aldehyde. So this is correct.